Okay, so what we're going to do today, if you think about what we've done so far in the syllabus, we did basically lists of data. So we did lists of data and a whole bunch of questions, and then we did grouped data. Now, when we go back to exam questions, we're going to see both types of questions. I want to know which type of question is this? Is this a question like one type of question, or is this a question two type of question? This exam question here. So is it based on lists of data, or is it based on grouped data? Tell me in the chat which type of question you think this is. Okay, so this isn't grouped data because there is a list of numbers you're given. There's no table. And so this is a type 1 type of question, a lists of data question. And this is a 10-mark exam question. Okay, so we're going to do question A, draw a box and whisker diagram for the data. However, in order to calculate or draw a box and whisker diagram, we need to calculate certain things. I want you to put in the chat, what are the 5 things I need to know in order to draw a box and whisker diagram? Because we're going to draw it in a moment, but I want to know what are the 5 things that I need to draw a box and whisker diagram. Pop that in the chat for me. Okay, so Sia Bulela has said the 5-number summary. You're absolutely right. What is in the 5-number summary? So Chlorny has said it's Q1, which I agree. There is a Q1, or the lower quartile. Well, let's make it. No. So Q1, there's a min, there's a max. You need to know Q2, and you need to know Q3. Okay, so those are the 5 numbers you need. Sometimes it can be also useful to know what n is. In this particular list of data, because there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, n is going to be 12. And that's another number that can be very useful. Okay, I want you to go ahead and draw me a box and whisker diagram for this data set. But in order to do that, you need to calculate the 5-number summary. So before we do that, I want to see the answers in the chat. And I'm going to give you guys 3 minutes to do that now. So go ahead, work out for me the min, the max, Q1, Q2, and Q3. And let's see what you get. Now that I'm looking at this, there is actually one other little thing we have to remember too. I'm interested to know if anybody spots it as we go ahead and begin this process. There's something about this list of data that looks interesting to me, and I just... Does anybody have a comment? Or I'm looking at the data and I'm just noticing something. Has anybody else noticed what I've noticed about the data?
Kumutsile noticed.
It's not arranged in order, Kumutsile. You're quite right. Do I need to arrange it in order? I think I do. I don't need to arrange it in order for the min and max, but that I can just see. But to find Q1, Q2, and Q3, I need to arrange this data from smallest to biggest. So actually, the very first thing I need to do is arrange this, and then I can calculate all these things over here. So when we calculate the 5-number summary, we have to make sure the data is ordered from smallest to biggest, or we say ranked. And in this case, they haven't ranked it, so you have to go and do that first. So I guess. Oh, I left something out there. Can you see what it was? Like I left out a 78. So let me. Move that out the way. Four, 5, 6, 7, 8, 9. I left out here. 85, 90. 84. I left out 84. That's 2. Okay, so once we have got our numbers written from smallest to biggest, they should look like this. So now I want you to find the min and the max. Are quite straightforward, but then you have to find me Q1, Q2, and Q3. And I want you guys to tell me what those are in the chat before we go on to the box and whisker. Okay, so Hariva has said that the minimum value is 10, which I agree with. So I see Hariva's got all sorts of values. So what is the important step I need to do in order to get the quartiles? I first have to find the position of Q1 and the position of Q2 and the position of Q3. So that is going to be an important step. It's going to be a quarter times n plus 1, which is going to be a quarter times 13. 3.25. So that is going to be between here and here. Sorry. Okay, so we should be getting, because these quartiles are between the two numbers, we have to average them. So halfway between 60 and 70 is 65. Halfway between 78 and 80 is 79. And halfway between 82 and 84 is going to be 83. So I have now got my 5-number summary. What I want to see is, can you draw me a box and whisker diagram? So use that information. Now, since you're going from 10 to 90, your number line is going to have to cover basically from 10 to 90. I probably started at 0 and then just go to 100. So you're going to have a number line on which your box and whisker is going to take place. Can you draw me a box and whisker plot? And once you've done that, why don't you just say BW done in the chat? Then I know that you're done with the box and whisker. Oh, what did I do there? Let's go 90, 100. So I'm drawing the straight line just so I have a number line to help me kind of. That goes to 90. Okay, so it's not, my box and whisker isn't perfect here, but you can kind of see that the box is here, and then we have the three, basically we have Q1 over here, Q2 over here, Q3 here, the max is over here, the min is down here. And that's what your box and whisker plot should look like. Okay, question B. So we've done question A. Tell me what the interquartile range is for this question. What is the interquartile range for this? Tell me what the IQR is. So the interquartile range should be Q3 minus Q1. Do you have what Q3 is? It's 83. Do you have what Q1 is? It's 65. And so your interquartile range should be 18. Awesome. Okay. Is the data skewed or not? And tell me, is it positively or negatively skewed? Or skewed to the right or skewed to the left? Tell me about this question C. Can you remember the discussions we had about skewness? Okay, so when we look at skewness, we kind of look at where's the data most spread out. And it looks to me like it's most spread out to the left, or we would say it's negatively skewed. So the data is negatively skewed because it's basically looking more stretched out on this left-hand side. So the answer for C is it is negatively skewed. Okay, D. Looking good, guys, looking good. Is 10 an outlier or not? Can anybody remember the criteria for an outlier? It has the number 1.5 involved. So is 10 an outlier? How would we check if it's an outlier? 10 looks like it's on the bottom end of the data set. It's not a very big number, it's a very small number. And so the formula we're going to use to determine if it's an outlier is the number less than Q1 minus 1.5 times the interquartile range. So I want you to think about that for a moment. Is the number 10, is it less than Q1 minus 1.5 times the interquartile range? And then I want you to give me an answer in the chat. That's for the lower limits of a outlier. So you know what the interquartile range is, and you know what Q1 is. And so work out what this, we call this the lower bound. And is 10 less than that lower bound? That's what I want to know. If it is less, then it is an outlier. If it's not less, it's not an outlier. Okay, so let's work out what this is. Q1 was 65 minus 1.5 times by 18. So 65 minus 1.5 times 18 is going to be 38. Now 10 is less than 38, and so 10 is an outlier. Okay. Kitsos asked, how do we know if it's negatively skewed? Going back to question C. Kitso, I'm mainly looking at the part of the side of the box and whisker plot that looks the longest or the most stretched out. So can you see how much bigger the yellow side is than the green side? And because the yellow side is the bottom 50% of the data, the green bit is the top 50%. Because the lower part is so much more spread out, we say it's skewed to the left or negatively skewed. Okay, just give me a quick thumbs up about pace. So thumbs up if the pace is good, thumbs down if the pace isn't good for you today. I just want a quick little vote from the class. Okay, so let's move on to our second question, unless there are any questions. This is an exam question where you do have to calculate something called the standard deviation. And so for some of you who were here earlier in the course, that's fine. For some of you, you may be feeling a little bit uncertain. So let's just try and start with this data set and try and calculate these first two questions. Now, the good news is it says the table below shows the number of cans of food collected by 9 classes during a charity drive. So each of these values is one class. Calculating the range shouldn't be too bad, but the standard deviation, you need to use your calculator, and what you need to do is the following. You need to go to mode and then go to stat mode. So turn on stat mode over here and then hit 1 for var. And then you'll get a data column where you put all the data that's here in. And you go 5 equals 8 equals and so on. Then once you've done that, you hit AC and then you click Shift and 1. And then you should be able to get to the screen over here where you're going to choose 3. So I want everyone to try and work out these first two questions for me. And when you have done that, you can put the answer in the chat. If you want a bit more help, then please raise your hand, or we'll take it from there. I'm going to watch the chat for questions, or if you raise your hand for questions. And yeah. So calculate the range and calculate the standard deviation for this question. And if you're really on fire, then you can also do 1.3 and 1.4 if you are done with the first two. So I see one answer so far. Sorry, yeah, when you hit Shift Stat, you'll actually get this screen first. I looked at my calculators in the wrong way. So you have to then, you go Shift Stat, and then you click 4 for var, and then you get this screen, and then you choose 3 for the standard deviation. This one over here. So range is 70, I agree, the range is 70. What's the standard deviation going to be? Let's do a quick little cheat and look at my answer here. Yeah. So we should be getting 19.56 for my standard deviation over here. Oh, okay. So if you're struggling with that, let me know. But for the rest of us, can we move on to question 1.3 and 1.4 then? I want us to do question 1.3, 1.4, and then draw another box and whisker plot like we did in the previous question. So Katlego was asked, how did I get the range? Katlego, I looked for the biggest value, which was 75, and the smallest value, and I subtracted them. Then I got the range. Yes, Renew, that's perfect. Okay, so let's see if we can get the median, the interquartile range. In fact, let's try and do the rest of this question, but initially 1.3 to 1.5 is what we want to do. I'll make these calculator things smaller. So I know n is 9. So whenever I do the median, I calculate the position. So I go a half. So the median is the 5th position. So the median should be 25. So the median is 25. So guys, remember when we calculate the median, we first calculate its position. And in this case, the median's position is the 5th position, but that's not the value. The value in the 5th position is the number 25. And so the median will be 25. All right. No problem, Siyabonga. Not a problem at all. I'm glad that yeah. Who would give me their answer for Q1 and Q3? Because that's what I need to get the interquartile range. So for Q1, I'm halfway between 2nd and 3rd. So that is going to be Q1 is going to be 8 plus 15 divided by 2, which is 11.5. And Q3, 6, 7, 8. So halfway between here. So 31 and 36. And we should get 33.5. So what is my interquartile range going to be? What's the answer for the interquartile range? Yeah, so we just go 33.5 minus 22, minus 11.5, and we get 22. So because of time, we're almost time for us to have a break. I'm going to jump ahead. We're not going to draw the box and whisker because I think you guys could all do that. But I want to use the box and whisker to help us comment on if there are any outliers and if there are any things like that. So let me just quickly get that question here. Let me just get that. I'll make that go away. And then, okay, so if I had to take the information I've got so far, that is what my box and whisker plot will look like. Now, what I want to know is in the chat, I want you to tell me about the skewness of the data. Tell me about the skewness of the data, so 1.6, and are there any outliers in the data? So basically, is the biggest or smallest one an outlier? That would be 1.7. So those are the 2 questions I want you to try and answer, and then we're going to take a break. So if we look at the top half of the data, that looks much bigger than the lower part here, or it's much more spread out. And so we would say that 1.6, this data is positively skewed, right? Positively skewed or skewed to the right. What about 1.7? Do we think there is any outlier here? The only one I would really check, if I think about this plus 1.5 that, if I look at this one, I can see that 1.5, I can see that that won't be an outlier. It's only the 75 I want to check. And is 75 an outlier? Well, the way I would check that is I would say, what is Q3 plus 1.5 the interquartile range? And we know that Q3 was 33.5, and then plus 1.5 times 22. So what number is that? Let's see. So the upper boundary, no, that does look like an outlier to me. So Q3 plus 1.5, have a look at this, guys. The biggest value in this data set is 75. Would you agree with me? So now if I take what Q3 is 33.5. 1.5 times the interquartile range is 1.5 times 22. So 1.5 times 22 is 33. And so that is going to give me 66.5 as my upper boundary. Is there a number in the data set which is greater than 66.5? I think the number 75 is greater. And so we would say that there is an outlier. The outlier is 75. Because 75 is greater than the upper boundary. Let's check that quickly. Yeah, so you can see that on the model answers here. Bring it down for a second. Oh, oops. So guys, if you look at this, the answer is 75 because when I'm looking for the upper boundary, there's a number that's greater than the upper boundary. Okay. If that confused you a little bit, don't stress. As long as you got most of those things right, you're on the right track. So let's have our halftime break now. What I want you to do is I want you to stand up. I want you to turn on your camera and I want you to stretch it out. Stretch it out for me. And then in a moment, I'll give you a nice special brain break. Okay, stand it up. And Lebo, if you could please give our students lots of encouragement to make sure they are investing in themselves by stretching it out.
Come on, guys, join in on the stretch. Give your brain
Don't
a
let me
bit
have
of
all the fun.
break.
Don't make me
Shout
start
out
doing
to
the hands,
Lee and
shoulders,
Lisanda.
toes, dance. There we go. So Komotsile has asked, isn't an outlier number smaller than Q1 minus 1.5 times interquartile range? Komotsile, you're correct, but there's also an upper boundary. So the one you're talking about is the lower boundary. So if it's lower than Q1 minus 1.5 times, etc., but there's also an upper boundary. And in this case, because it's skewed to the right, we're checking the upper boundary at this stage. Okay, to answer your question. All right, has everybody had a good stretch? If you've had a good stretch, give me a thumbs up in the chat, please. And then I'm going to give you a new type of brain break. Okay. I feel a lot refreshed from my little thing. Okay, here is the brain break for today. It's a bit different. That is a mathematical word. I want you to tell me what is that word. What is that mathematical word? What is that mathematical word? I'm going to do some more stretching while you guys figure this out. Who can figure out what mathematical word can you make from those letters? Lee, I think you've got it. So Lee has said, does anybody else, I'll give you a moment or two more. You can make the word subtraction. Subtraction. So subtraction. Very nicely done, Lee. Let's do one more of these. Did everyone get that? So what you have to do is make a mathematical word using these letters. Okay. Let us do one more. I want you to tell me what mathematical word can you make from these letters? Hey, you guys are so quick. Okay, Zinkler and Novoseto, you're quite right. This is the mathematical word arc, which is like basically a curved line on a circle. Awami, yeah, you guys have got it. Okay, love it, love it. So I hope that you have had a brief break, that you've had a bit of a stretch, and let's return to some further old exam questions. So, nice quick one. Hopefully you get a nice one like this in your exam. Mr. Brown conducted a survey about airtime. He summarized the data in a box and whisker plot. Answer for me these three questions. So answer these three questions. And when you're done with the three, just put done in the chat. But you must do all three of these questions. And then if you have got the answer and you're willing to share, why don't you raise your hand and then you can let us know audibly. It'll go a bit quicker. So this one is a bit quicker. Maybe someone can let us know on the audio channel. Okay, Lusanda, let's go to you. I'll unmute you. Hi, Lusanda.
Hi, sir.
How's it going?
I'm good, and you?
Very good. Tell me, what is the 5-number summary for this data set?
It's the mean, the max, Q1, Q2, and Q3.
Okay, so it's not, you got 4 out of 5. It's not the mean, though, it's the median. But tell me what the values are. Can you get me the values from the box and whisker plot? What's the min?
The min is 12. It's 10.
Perfect. Yeah. What's Q1?
Q1 is 17.
Perfect. What's Q2?
30.
Yes. What is Q3?
38.
Perfect. And what is the max value?
The max value is 65.
Perfect. Thank you, Lusanda. 2 marks in the bag. Lusanda, do you know what the interquartile range is here? Could you read that off straight from here?
Oh, it's Q3 minus Q1, which is going to be 38 minus 17, and then you get 21.
Awesome. Okay. And since you've almost done the whole question, what about 1.3? What is this data skewed and how is it skewed?
I think it's positively skewed.
I agree with you. It is. It's skewed to the right or positively skewed. And the reason I can see that is the top 50% of the data is way more spread out than the bottom 50%.
Okay.
Awesome. You did really well, Lusanda. Okay, so that was hopefully you all get exam questions like.
Same days.
No problem. Let's do a grouped data question. So let's do one like this. Okay, so change of scenery now. So instead of doing a list of data, I'm giving you a grouped data table. And this table is saying, it's showing the age of different people, and then it's got a frequency column and a cumulative frequency column. I want everyone to try and do these 3 questions for me. We'll leave these 2 for now. We'll leave the red ones for now, but just try and do the blue ones. And if there are any questions, you can ask me. But basically, you have to figure out the missing spaces and then answer those questions. Off you go. A good place to start would be here, huh? What is this number over here? How do we work out? Who has a suggestion? Maybe someone can even raise their hand and help me. How do I, if I know this is 27 and this was 7, what does this number have to be? Who has any ideas? While students are working that out. People are saying 20. And I agree, because the cumulative frequency total is 27. This has to be 20. So basically this and this have to give me that. So that would be 20, yes. And then this one is going to be, well, I'll let you keep on working that out actually. So that should be 52. What is this going to be? Who knows what that's going to be? So if that's 52, this is going to have to be 12 to get me to 64. And then this is going to have to be 8. And then this is going to have to be 76. What's the last one going to be? Yeah, so this one has to be 4. Okay, so this is a different type of question which we haven't seen before, but you can see how you have to understand what a cumulative frequency table is. So how many people participated in the survey in total? How many people participated in the survey? That's what I want to know next. Okay, and so the total is just going to be 80 because it's the number at the very bottom. There were 80 people who participated in this survey. What is the modal class? 2.3, what is the modal class? What do we need? If we think of the mode, what does the mode mean? And remember, this is grouped data, so we can't have an exact mode, but we can have a modal class. So we're looking for the class that has the highest frequency. Which one has the highest frequency? 25 is the highest frequency. And so the modal class would be 40 to 50, or the way they've written it here. I suppose we should write it like this. Like that. Perfect. We're not going to draw an ogive now because of time, but I do want to ask you for 2.4, what would the next step be? So you're given this table, and if you were going to draw an ogive, there's a next step that you need to do. And I want to know from you guys in the chat or by raising your hand, what is that step? Yes, so it's an extra column for the point. And then once you've got that extra column, you basically go to the end of the interval. So that would be 30, and then it would be 7. And then for the next point, it would be 40, 27. So I'm basically, and this is we did in a very recent lesson, that's why I'm not going to go into too much detail, but it's basically going to be those, the end of the interval and the cumulative frequency and so on. And then we just add one additional point at the very beginning of the ogive with a frequency of 0, because that's how we get to the very beginning. So there's one extra interval over here and 0. And on the cumulative frequency ogive, it's just going to basically be so it gets back to 0. Okay, now I'm going to show you what the ogive looked like. Actually, how much time have we got left? No, in fact, let's go on to another question. I'm not going to do 2.5 now.
Mr. Ace?
Yeah.
There's a question to please repeat how to find the modal class.
Okay, so the modal class, if you think about what the mode means, the mode means the thing that comes up the most, right? The most often, which thing occurs the most, and if you look at this grouped data table, the frequency tells us how often something comes up. So which of these frequencies is the highest? 25 is the biggest frequency. And so the grouped interval that comes up 25 times is going to be the modal class, which is that one there. Okay, but there's not enough time to go on to a whole other question. So let's try 2.5. 2.5 is a slightly harder type of question, but we'll have a quick look at it now. I'll just explain how the answer works. So it says here, determine the percentage of marketing calls received by people older than 54 years. So 54 years on my ogive, I go and find, let me just break it into pieces. So I find 54, over here on my ogive, and it's going to get to there. Now, if I go 54 years of age, that means basically if I go to the left here, so guys, I don't want you to stress about this question because this is definitely a much, much higher level one, but it looks to me like we've got 58 people. So if we have, in grand total here, we have 80 people in this whole ogive, right? So we can see there's 80 people in this whole ogive. We can see that 58 of them are younger than 54 years. So 58 people are younger than 54 years. How many people, I want to ask you, how many people are older than 54 years in this question? So how many people are older than 54 years? It's basically going to be these people over here. So how many people are older than 54 years in this question? Who has an idea? So, there's 80 people in total. 58 people are younger than 54 years. How many people are older than 54? Yeah, so you go 80 minus 58, which is 22 people. So 22 people. Now, the question says, determine the percentage of marketing calls received by people older than 54. In order to get the percentage, all you do is you take the number of people over 54 and you divide it by 80, which is the total, and then you times it by 100. And if you do that, 22 divided by 80 times 100, you're going to get 27.5%. Now, that is a tough question. And we haven't done a lot of those. We'll do a few more of them in the next lesson. It's basically what we call an interpretive ogive question. But yeah, we'll do some more in the next lesson. Okay, so guys, I'm going to call it there for today.